Okay, so actually I wasn't aware that this was going to happen, but in your bags, you got this book. And so I thought I'd start with this book anyway, and there's a quote from me on the back that this is the IT swamp draining manual if you're up to your if you're knee-decking alligators, which is, But the thing about this book is that it talks about a company that's been overtaken by events. It's a company that's just like a regular manufacturing sales company that years ago, IT was a small piece of their business, and it gradually gets more and more significant. They don't really deal with it, and it's about the transformation they go through as they try to deal with the fact that IT is now central to their business. And so why has this happened? And so I'm going to actually pick up on that part and talk a bit about what has happened to the industry over the last 10, 20 years. We used to have, this company used to deal with POS terminals, right? And they had employees. They had a few thousand POS terminals maybe and a few thousand employees. And once a week they updated the advert in the local paper, right? That was their IT had to go deal with that. And IT probably didn't even have to deal with the advert. But they went from POS terminals to an online presence. And now they've gone from thousands of POS terminals to millions of sales, millions of web transactions. They've gone from thousands of employees to millions of customers, and all those customers want personalized information and all kinds of things like that. And their advertising has now moved to real-time bidding on the latest stuff, and depending on what the weather is, you'll put up a different advert and all those kinds of things. So this is the same company, even operating at the same scale, over a 10, 20-year period. This is like a 3 orders of magnitude increase in the stuff they have to deal with. They've gone from thousands of entities to millions of entities. So that is happening across the world as people are trying to compete in this world. If you don't track that, you'll go out of business. So over the years, they started off with a mainframe scale system that was just doing payroll or something like that, a bit of manufacturing, and then they did some client server, and then maybe they went to commodity, and now they're trying to figure out web scale cloud stuff. So that's the arc that people have been on. And a lot of the mindset that you start with was set in the early days. So if you started off in a mainframe world, then you're used to running reliable hardware. Mainframes just don't fail. That's the point of a mainframe, right? And it runs stable software. You spend a year making your software really solid so it doesn't break. And this is the base assumption of a lot of IT. And the trouble with this assumption is that it's kind of fading into the distance, and what do you do now, right? These assumptions aren't valid anymore. And what I'm seeing is a lot of people looking around for, well, how do we deal with this world? And I've been going around giving lots of talks to people, and this is kind of a summary tweet of what I generally, it looks like, I'm sort of baffling late adopters as a service. It's like, we do all this stuff. Oh my God, we couldn't possibly do that, has been the reaction. I mean, 4 years ago when I first started talking about Netflix, the reaction from the cloud community was you couldn't possibly be doing what you say you're doing. And then eventually they agreed we're actually doing it, but we're a unicorn and no one else was going to do that. And then it moved on to, well, actually, I guess people will eventually try to do that. And in the last year, I think we've seen major brand name companies you've heard of that aren't at all really the bleeding edge technology companies are talking to us and talking to other people that are doing web scale about how just they're in the middle of doing it now. I mean, it's no longer we're a unicorn out in the wild. Well, how do we do that? Because if we don't become agile, continuous delivery, cloud, if we don't get on top of that, we're not going to compete. So what happens? Well, if you're running at scale, scale breaks hardware. Right? If you have enough hardware, it scales. So let's assume you have 1,000 times more hardware than you used to have. Some of it will be broken at any point in time. If you keep deploying hardware, eventually you hit that scale. And if you keep changing your software, effectively speed breaks software. So if you're continuously updating your software, occasionally you'll push something that's broken, and the dependencies you have, some of those will be broken because you haven't spent a year tuning and testing it, getting it perfect. It's better to get it out faster. And if you do speed at scale, it breaks everything. And this is the this is web scale. This is the world that we live in. And even if you're a small company, if you're going fast enough, then you will continually be breaking your software and breaking your systems. And you have to build systems that assume that everything they talk to could be broken. And how does this apply to Netflix? Well, there's this Yeah, strange world of the future. Stranded without video, no way to fill their empty hours. It's snowing on the East Coast and the kids are home from school. It's very important that those iPads have Netflix on them. And we don't want to end up with the cloud of broken streams. So what are we doing about it? The way we think, so I'm going to talk a bit about availability. I've talked a bit about the scale, and then I'll get into the speed part. How do we think about incidents and mitigation? So at the worst thing that can happen is what eBay used to call the CNN moment, which is your website's down, but it's on the news, right? Right. People who have never been your customer and know that your site's down. That is a PR event, right? So we want to avoid those. That's media impact. The next worst one is that customers are calling customer service. It didn't make it to be a PR event, but the customers are annoyed. And if a customer has to call customer service, they might quit. Right, so you don't want to annoy people. The next one down is that customers have no idea that something's broken, but you're not actually giving them the feature set that they're supposed to get. And if you're doing lots of A/B tests, you're giving people different sets of features, and if they didn't actually get the feature they were supposed to get in that test because the test was broken or something else broke, you need to understand that, and those cause issues internal to us. And then, fast retry, I'm sorry this request took 100 milliseconds longer than normal, you won't notice, right? But that's this service just auto-scaled down and that machine's no longer there, and when you tried to call it, sorry, it's not there anymore, fail over to the next one, keep going. That kind of thing happens every time we auto-scale up or down or do a code push. So that's a sort of order of magnitude. Hopefully there's a single-digit number of PR events a year, and working the way down at sort of a 10x on each scale here. So what are we doing about this? What we're doing about the top level ones is that we're doing active-active, which is we're running the whole of Netflix, East Coast and West Coast. This is what we've been working on all year. We'll be talking more about it at reInvent in detail, but I'll just show you what that looks like shortly. And we're doing a little bit more practicing of flipping over between these things, and something that we really need to get better at is game day practicing. And the way to think about that is it's really annoying those fire drills in your building where you have to go stand in the parking lot for 10 minutes every 6 months, except when the building is actually on fire and you're in the parking lot and you look around and all of your team is there. Yeah, that's a good feeling, and there is nobody in a smoke-filled room somewhere in the building. So those practices are annoying. But if you don't practice them, then when the thing really happens, no one knows what to do, right? So you have to figure out how to set up something that looks like a game day practice. Otherwise, if you build an incredibly reliable system, when it does break, no one knows what to do, and we've had that happen a couple of times. Better tools and practices, just tracking all changes in the system. Every time you change a dynamically changeable configuration variable, we log it into a central place that you can see that just after that, everything went to hell in a handbasket. So it's probably that change, turn it back, that kind of stuff. And then better data tagging. So if you tag the experience everyone gets, then the person that actually was using the site at the time this feature wasn't working, you can say, no, they didn't get that experience, so you clean up your data tagging. So that's actually, keeping your big data stuff clean actually keeps the internal people happy. So this is the kind of stuff we've been doing. In the architecture, what this looks like, you have customers, we have East Coast, West Coast, it's lots of Cassandra, there's triple replicated on the East and triple replicated on the West, we have DNS routing traffic back and forth. And if stuff starts going wrong, say this service in this zone goes wrong, we don't care, it just keeps working. Some more services go wrong. This is all still a perfectly working system, no customers won't notice anything. We lose an entire zone, that's a whole data center worth of stuff, yeah, it'll keep working, we've had that happen a bunch of times. If you lose a whole region, we go, okay, well, we need to turn off traffic to that region, but half the customers were okay, and we can switch the other half over in half an hour or something. So it's a minor outage rather than being like all over the news outage. This is the plan. And if one of our DNS vendors dies, we switch to a different DNS vendor. So we've kind of abstracted all that stuff together. So that's kind of web scale architecture, making it highly available. This is very scalable, it's globally scalable, it's scalable in terms of traffic. We're doing ridiculous amounts of traffic into this thing. So let's move on a bit. So how do we speed up delivery? You have your CIO saying, speed it up, we need to go faster. And so what does that really mean? Why do you need to speed it up? Well, you're competing with other companies, and those companies are going, you're in kind of a dogfight. And if you go to one of the ways of looking at this is the OODA loop, some of you probably heard of already. This is from the Korean War. The pilots that came back from the dogfights were the ones that could think faster and react faster than their opponents. And you want to come back from a dogfight because the alternative is your plane crashed or you didn't make it back. So what does that actually look like? Observe, orient, decide, act. That's the loop we're trying to get around. And from a business point of view, the observe part is you're looking for a land grab opportunity, you're looking for a competitor made a move, you want to react to that, or you spot a customer pain point, you want to do something about it. So okay, so you figured out something that needs doing. Then you're going to do some analysis, and you're going to model some hypotheses. Hypothesis-driven development, it's a new buzzword, watch out for that one. Hasn't quite read an early version of Jez's book. And then you're going to plan a response, get buy-in, commit resources, okay? How long does it take you to do that? Just to decide what you're going to do, or if you're going to do it. Then implement, deliver, engage customers with what you did. Say, hey, look, we did this thing. You're going to point customers at it. And finally, you're going to measure the customers. And now you're going around this loop again. This is your feedback loop. So the question is, how fast can you go around that feedback loop? And can you go around this faster than whoever you're competing with in whatever market you're in? That's the trick. So let's look at the evolution of this. So let's start, every conference opening keynote has to start with mainframes, right? We've got more mainframes later. So, okay, let's look at what it was like in mainframes. So we have the big blue version of this cycle, right? So, did it all in blue this time. So we're trying to expand territory. We have, think of it back in the 80s, something like that. We're going to take over, we're in Wisconsin and we're going to take over Illinois, right? That's kind of the territory. The Japanese are coming, they're making cheap, better stuff, whatever. Or you actually did spot a customer pain point you wanted to deal with somehow. You have systems analysts. Remember there used to be people called systems analysts? And you do capacity modeling. You probably spent 3 months building a detailed queuing model of exactly what you were going to build so that you order the right mainframe eventually. You put this in your 5-year plan. You have board-level buy-in because this is a massive amount of money, and then you start evaluating all the vendors, all the software. Then you customize the vendor software, and you upgrade your mainframe, and you put out your print ad campaign, and then you see whether you got any more revenue the following year. So this is like a year-long release cycle, and this is that would be considered state-of-the-art, reasonably agile 20 years ago, right? So it's like $1 million to $100 million investment. You're betting the whole company. If you fail, you probably go bankrupt or get bought, right? We've seen companies botch a product launch or botch an IT rollout and just really go out of business. And that's kind of what's staring the Parts Unlimited in the Phoenix project in the face. They're going to outsource IT or go out of business if they don't get this right. And it's probably like COBOL and MVS and all that stuff. So then a few years later, that's before the time I was in the industry, but I used to work for Sun. So I made this purple because Sun was the purple, kind of little purple feet on our machines and things. And I figured, you could probably turn stuff around in 3 months in this. So you're still solving the same problems, except maybe it's like China instead of Japan, or is the new foreign competition or something. And this time you built a data warehouse because Teradata's, you could buy those kinds of things now. And instead of doing modeling, you're doing capacity estimate because you wanted to do it in a week instead of 3 months. And you have a 1-year plan, and you really only need CIO buy-in this time. You don't have to go all the way to the board, but you're still doing vendor evaluation, customizing software, installing servers, but you're now doing TV advertising instead of print advertising. So the world is really moving on here. And again, you measure revenue. Maybe your quarterly revenue, you can see a difference now instead of annual. So it's speeding up. And this is kind of, I was working with customers in the 90s that were kind of, this would be state of the art. If you could get something out in 3 months, you were going pretty quickly. So, 3 months to a year, you're sort of 100K was sort of the minimum entry price to get into this, up to some pretty big deals. And it was sort of C++ and Oracle and Solaris as sort of generic things, or HPUX or whatever. But the general idea here. But if you failed, you got a revenue hit, and maybe the CIO lost his job. And the company's not going to go out of business, but maybe the CIO gets hit on that. So then, moving on a bit, back in the early 2000s, I was at eBay. And we had a 2-week Agile train. This was like excellent stuff. A lot of people are actually still running on this kind of train. So I call it RED, maybe Gateway or something. Dell, I don't know. You've got your basic commodity machines. Same kind of problems you're trying to solve. You still got a data warehouse. You're still doing estimates. But you've got a 2-week plan now. It's like, what's on this train? That's the plan. Your business does buy-in. You're prioritizing your features. This is all nice and agile, and you're getting stuff done in weeks. and it's about a code feature is what you're acting on. And you install a capacity, you do web display ads now, because display ads are cool, and that's why Google made all their money. And you're measuring sales directly. So this is getting to be kind of what a lot of people are actually in right now. So, it's much cheaper, another order of magnitude cheaper. Everything's happening in weeks. Cost of failure is the product manager's reputation. Maybe 2 weeks later he gets it right and everyone's happy. It's not such a big deal, so that's good. And it's sort of Java, MySQL, Linux, something like that. So when you're doing this, there's a bunch of handoff steps. The product manager tells the developer what he wants, and then the developer builds it, and then he gives it to QA, who integrate all the work by all the developers that's going to go into this train, and then they give that to operations, who go and deploy it, and it breaks, and they go back and forth a few times trying to get it to work. And eventually the BI guys build a report that says, this is what happened in this train. So that's reasonable. So what happened here? The cost and size and risk of change reduced, and the rate of change increased, right? So this is the trade-off. So where do we go from that? What's the next step? So what we've been doing, we call cloud native. We're constructing this highly agile and highly available service from ephemeral and assumed broken components. It's not that we expect them to be broken, you just have to assume. The default assumption should be that any request you make to a service is likely to fail. So you should actually practice, what does your code do if this thing fails? So you don't assume everything's working. You flip that assumption, and then you build very different systems. And that's really the mind shift that you have to get through, and it's one of the ones that a lot of developers and a lot of enterprises have trouble with. So you end up building a system that looks a bit like this. This is actually a year or two ago what Netflix's homepage looked like. These are all the individual services. Each of those icons is actually probably hundreds of machines scattered across 3 different buildings or 6 different buildings. This is just to service the homepage. That's that homepage when you visit Netflix. This is the web of different HTTP requests and memcache lookups required to just render the one page that you get back when you first visit. So it's pretty messy. If we lose a service, you don't even notice. One piece of functionality on the page isn't there. Everything keeps working. It sort of routes around it. You get a different row of movies, or your movies aren't quite as nicely personalized as you think. So how are we getting that delivered really quickly? So continuous deployment means I'm trying to deploy stuff, and I don't have time to have that bi-weekly meeting with IT because I'm doing it 5 times a day, and I can't go meet my IT guy 5 times a day. It'd go crazy, right? That doesn't work. So because there's no time for this handoff to IT, the developers have to do it themselves. So what you've got now is developer self-service. The developer is putting code into production themselves. They're responsible for it. They click the button. They take the stuff to live. So that's a freedom that developers get, but then they're also responsible for what they put there, and you have to hold them responsible for it. And if they do stupid things a few times, you find a new developer, right? So there's an element of peril here. And if you don't have any peril in the system, it kind of gets out of control. I mean, there's this idea that cars, instead of having airbags in the steering wheel, should have like a 6-inch metal spike sticking out, because then you would actually drive, if everyone had it, everyone would drive around really slowly and carefully, and there would be many fewer road accidents. Occasionally someone would get spiked a bit, but overall it would probably, everyone would drive around very slowly and carefully. And if you give everyone airbags, they drive like crazy because, if they crash into somebody, all that's going to happen is they're going to get, airbag rash or whatever. So there's this sense of having a little bit of peril in the system causes people's behaviors to actually get well aligned with the outcomes, right? So we have developers running what they wrote, which means that they get root access in production. And some people go, oh my God. But we put them on PagerDuty, right? So you get both here. We're going to call you at 3 a.m., and we're going to give you all the ability you need to fix it, right? You don't have to call anyone else. You have to wake up the IT guy as well. You wrote the code. It's in this. You know exactly what state it's in. You're changing it 4 or 5 times a day. It isn't time to transfer that information into somebody else's brain so that they can operate it for you. You have to go back to that. And it turns out that the developers actually spend less time managing stuff in production than they used to spend talking to IT about how they were supposed to manage it in production. So there is a net actual reduction in the amount of time you spend worrying about operations, because you end up building code that's more reliable in production to start with. And because you're on hook, you can resolve things really quickly. And it doesn't happen that often. But yeah, occasionally you'll get woken up at 3 a.m. because something bad happened. So what is IT in this world? IT is a cloud API. Right? I don't really care whether you're running internal IT or whether you're getting it from a public cloud vendor. The way you talk to your IT department is an API. And for us, our IT department is AWS, and we talk to them once a week on a con call, but we don't talk to them about provisioning individual machines. That's happening all the time. If you're big enough to run your own internal cloud, then you shouldn't have that. There shouldn't be a conversation about a deployment unless you want to deploy something that's so big you're going to run out of a resource. So this is sort of DevOps automation with the accent on the dev. This is the developer side. I mean, DevOps is dev and ops coming together, but starting with the developers and teaching them to do operations. That's the flavor of DevOps that Netflix has been doing. There's another flavor where the ops guys figure out how to automate their stuff and they're learning to develop things. So that's coming at it from the other direction. And sometimes we kind of miss a bit in the middle, but that's generally what's going on. So another thing that we saw in those other loops was like the vendor evaluation and customizing vendor software. We don't do that anymore. We get everything from GitHub. And if it isn't on GitHub, we write it and put it on GitHub. And everything's Apache licensed. And so that whole vendor cycle is gone now. The major dependency we have, external dependencies, probably Cassandra, and we have our own committer. We're contributing code, we're jointly developing code in public with a whole pile of other people, lots of other companies, to make Cassandra better and better. And that's our major, that replaced what we used to do with Oracle. Right? So this is, and if we want something, we know exactly where the code is and we can change it ourselves if we need to, and we can discuss it. So what that means is that we've ended up putting a lot of stuff. This is what Netflix's GitHub account looks like. We borrowed some code from the UI team. And we found some icons because we own the icons for genres, it turns out, but not for anything else. So randomly assigned genres. But we have 35 projects there, and we have a few more coming in the next few weeks. But this is, from 2 years ago, we had one. And this is kind of us engaging with the community, putting a platform out there, consuming stuff from outside, putting stuff out there, filling the gaps. So putting all that together, let's do continuous delivery on cloud. What does that look like? So going back to that original thing, we're still looking for land grab opportunities. We're still reacting competitive moves. We're still looking for customer pain points. We're doing analysis, we're modeling hypotheses, we're doing A/B testing of a piece. And the iteration loop here isn't even a feature anymore. It's maybe one line of code. It's a step towards a feature. You can put all these steps into production continuously. You could be checking, every check-in could flow all the way through. You're going to plan a response, you're just going to do it. Because we empowered the developer to decide to put it in production, so you don't have to do any board meetings anymore, which is good. But you have to share your plans. You have to communicate to people, this is what I'm doing, so other people know, and if there's any implications, they know that you did it and what you're doing. So instead of asking for permission, it becomes sharing your decision. And then there's an incremental implementation. We're automatically deploying, and you're launching. The end point here is that eventually you get the thing into a state where somebody's going to launch an A/B test, and then you're measuring customers, and you're measuring an A/B test, a subset of customers behind a feature flag and all that kind of thing. So what this is typically known as is this is the innovation part, and companies say we have trouble innovating. They mean they can't see the stuff, they can't see the grumpy customers in front of their very eyes. This is also known as big data. And what's interesting about big data to me is I want to be able to quickly answer a question that nobody has asked before. So traditional BI is you get the same weekly report saying we made some money this week, good, right? That has to be done accurately and all those kinds of things. But I want to know, is this customer pain point real? Who has it? How many people are hitting this piece of the site, right? There's a broken link. How many people are hitting that broken link? Those kinds of things. And then you build a hypothesis about, well, if I do this change, it will make this customer happy. You loop your way around, and a day later or whatever, you've got data. This part's culture, the culture of giving permission to do stuff all the way to the developer, because we're going around this loop in hours now. There isn't time to go ask people for permission to do things. And this is basically cloud, whether you're doing it internally or externally. What you're doing is trying to get minutes to deploy stuff. right? That should be what you're looking at. So what does this look like? The cost is kind of near zero. It's variable expense. If you turn stuff off again, you stop paying for it, which is nice. So you can deploy, shrink things back. You're not committed to a 3-year depreciation cycle for what you needed to roll this out. You're in hours, maybe days. What you're betting is a decoupled microservice code push, like one of those little dots on my big diagram of all of those services. I'm changing a line of code in one of those. That's my bet. And the cost of failure is near zero. I'm running A/B tests. I'm running red-black deployment, so I have the old code running alongside the new code, and I can flip back and forth. It's all going to work. Kind of languages have moved on a bit, and we're still mostly using Java, but we've got quite a bit of Scala and Python now, and we're starting to poke a bit at Clojure. And you're running on NoSQL on cloud. That's sort of what the world looks like. And so those continuous deployment handoff steps have collapsed now. There's a product manager, and the product manager says, I have a hypothesis. I'm going to create an A/B test. Here are the different experiences I want. They actually self-service creating in the system the A/B test itself. The developer writes the code to implement those variants. Build some automated testing to do that. They deploy the code, they're on call for it, and then they have some self-service analytics to say whether their code's running or not. And once it's all in place, the product manager will actually allocate customers to the A/B test. And then they will actually see the results come through, statistically valid, all the statistics is done for them. So this is all a self-service layer of systems. And there's really only one handoff that says, please implement this A/B test. That's the next thing I want you to do. And then everything else is basically done. So we're building some automation to support this. First of all, you check in code. Jenkins build happens. We bake an AMI. You launch it in your test environment. This is like, from check-in, everything else can flow through and be automated. We're not quite there, but we're getting there. There's a functional and performance test. So the functional test is it broken? Okay, looks good. Then we do a little stress test to measure how many requests per second that code can take and compare it with the previous one. We do side-by-side testing. And then in production, we do a canary test where we take the old code and the new code, and we start a fresh version of the old code alongside at the same time as a fresh version of the new code, give them equal traffic and see what happens. Do some signature analysis. I'll show you what that looks like. And then we roll forward into a production red-black push where we stand up the new version of the code. We leave the old ones there in case something really breaks quickly. Then you can flip back and forth between them. So that's the flow. Flowcon, good. So we're trying to automate all the steps in that, and we haven't got all of it done, but we're getting fairly close to it. So Roy's in the audience, and one of the engineers working for him gave me some slides, so some screenshots. So we have signature analysis where we take a canary in production and we run statistical analysis of whether it's better or worse than the previous one and what's variable. And this is a bad canary, and if I zoom in on this bit of it, you can see that the little red dots off to the right are the mean and the median for that measurement, which is way out of the acceptable range. So this is a canary we'd reject because it's behaving in a way that is unhappy, right? And we've got a few metrics that are okay, a few that are noisy, one that's better than usual, so it's blue, it's a good one. And overall, we'd reject this. So say this code, bounce it back, go fix it. What did you do? You broke something, right? This is what a happy canary looks like. It's all green, or I'm not sure. The not sures are close enough. Basically, you can see that if you look at those, the width of the little sort of variant things are very narrow, and everything is within the right range. So the software to do that, we're working on it. We're trying to build a flow that uses this as the gate to production. And at the moment, it's like, it goes back to the developer and says, here's the result. Are you happy with this? Do you want to hit go? So we reduced, instead of all the manual steps of deploying something, it's a one click. And it says, okay, take that one through to the next step. So then we've got a happy little canary, and we've got some code, and we've got it running. But we actually have 3 different sites, 3 different regions where we're running everything. So this is the other kind of automation we want. So it's afternoon in California. You've been developing code. You think you've got something. You check it in. It passes tests. Then you want to deploy it. So we deploy it to Europe because we have some machines in Europe, and it's nighttime in Europe, and Europe's a small site, and it's night, so there's very little traffic. So if we totally break everything, relatively few customers are inconvenienced, and they're a long way away. But this is, yeah, we're kind of working towards this. So, and then we we run the canary, we make sure it works, we sort of scale it up and everything goes and it's fine and it's running. And the developer is there, it's at work, looking at this, they get the reports, yes, this looks good. Then the next day, they come in and it still looks good overnight because it's been through peak now in the UK, following morning. So then you can deploy to US East or US West. So pick one of the US sites and we automatically sort of, we can set this up so the workflow, there's a Groovy-based DSL we came up with called Glisten, which talks to the Amazon simple workflow. And we're using this behind our Asgard tool to just try and sequence these things. So you can kick off a push that automatically rolls around the world, it shipped to the next day if everything works, that kind of thing. So again, we bring it up and we go through the canary process again because the state and the initialization is different enough that you don't want to just kind of assume that it's working code. So we run it through the canary process again, and then maybe the next day we'll roll it to the West Coast. I mean, you can choose how much delay you want to put in this, but conceptually, you could do a check-in. It could go through all this process automatically, and if you wanted to just hands-off do it, you could roll everything all the way through to production, and you could be continually creating these. We typically run the canary for a few hours to get valid data on it, statistically sort of clean data, but you could shrink that time if you really wanted to. So that's what we've been doing. That's kind of flow for us. There's a couple of things I want to just wrap up with. One is the inspiration side. All of the things we were doing around cloud native, we have all of these great sources. So I wanted to give them some credit. Michael Nygaard, a lot of you probably know Michael. Release It contains bulkhead patterns and circuit breaker patterns and all the things that ever went wrong when trying to deploy code, and we've built systems to deal with a lot of those patterns. Thinking in systems is not really about software, it's about the overall sort of feedback loops and how to build systems which have the right emergent behaviors, right? If you set systems up in one way, everything goes to hell, and if you do it the other way, everything goes happy. So it's about thinking about things in that very systemic way. The REST API Design Handbook by George Rees is he's been coding to all of the cloud APIs for years, and there's a lot of brokenness in there. So it's a lot of don't do this kind of stuff. It's a very short book, but basically he was like ranting on Twitter distilled into a book. Oh my God, this cloud vendor is so broken, kind of stuff. Anti-fragile, what we're building is a system, we're trying to build a company and a system which is anti-fragile in the sense that we continually attack it to make it stronger. This is, think of, if you're not run into the anti-fragile idea before, think about just working out, right? You go to the gym, you're not used to going to the gym, so you're going to go and you're going to work out, and at the end of that day, you feel really bad, you hurt, right? So why would you do that? It hurts, right? But the next day you feel a bit better and you're a little bit stronger, and you keep doing it again and again, and you get stronger and stronger. So this is the concept, right? By damaging a system slightly, stressing it slightly, it gets stronger. And if you don't stress yourself, if you're completely out of shape and flabby, and the first time you need to go run for a train or something, you have a heart attack, right? That's the failure mode, right? You want to build up the ability to deal with sudden attacks, sudden stress coming into your systems to deal with it. Drift into failure. I always say this, but anyone getting on a plane soon, don't read this on the plane. It's mostly consists of aircraft falling out of the sky kind of examples. The rest of the examples are about people dying in hospitals. So, but it's about how a sequence of perfectly good decisions made with all the local sort of knowledge available will build up to a tragic failure, right? So the tragedy of the commons kind of failures happen because everyone is optimizing for the information they have. Nobody is to blame, but the system will end up in a big outage. And so that's kind of the drift idea. Then there's this continuous delivery book some guy wrote. Anyway. If you're here, you probably know about that already. I'll make it up. And then everything is obvious. So if you're trying to build systems that are operable, then when you get into the incident review for something going wrong, you say, well, it's obvious why it was going to go wrong. Why didn't we see that? Right? Well, you didn't make it obvious. So thinking about how do you make things obvious? How do you make it obvious that when this problem happens, you push this button and you pull this lever in this direction? Because quite often when things go wrong, people do the opposite of what they should be doing because it's not obvious. You know, oh, the machines are all messed up. Let's reboot everything. Usually that causes everything to completely tank. It's like we've been trained by our Windows PCs that the answer is to reboot everything, but it turns out there isn't. In most cases, if anyone says in the middle of an outage, let's restart everything, just say no. It's probably a bad idea. And then cloudonomics, if you're trying to figure out whether you should have stuff on premises, off premises, all of the sort of economic modeling for cloud. That's Joe Weinman's book's really good. And I was hunting around and I found there's another book coming out soon, this one. So make it up to Jez. All right. And I actually got to read a few bits of it, so I was looking forward to this coming out. So here's my takeaway. Speed wins. Assume stuff's broken. There's cloud-native automation is the way we're getting everything done. And then GitHub has become both your app store and your resume. And it's a resume as a developer and as a company. People look at Netflix's page on GitHub and go, I'd like to work there. We have all that interesting stuff you're doing, right? And we go and look at when somebody wants a job at Netflix, we say, oh, what's your GitHub ID? We'll go read your code. We don't need to have you stand and scribbling on a whiteboard. I can read what you've done over the last few years. So that's it. So I'm going to end with an A/B test hypothesis. My hypothesis is you'd actually prefer the Scooby-Doo ending. What do you think? We'll see. So there we go. That was continuously delivered at about 10 to 9 this morning. All right, so that's it.